In this video, we're going to talk about how to determine infinite limits. The situation that we are facing is going to be, you see that at a point A, sometimes the function behave in the way that when you have x go to A from the left side, it's going to tend to the very large number without an upper bound. So in this case, you see that the behavior of the function is going to tend to infinity when x approach to A from the left side. And from this picture also that if you are having x approach to A from the right side, you're going to see that your function is going to become lower without an upper bound. So it's going to be very negative large in this case. So the notation that we shall use to say something from this graph will be limit x go to A from the left of fx is equal to positive infinity. So it means that limit x go to A of fx turn out to be very large. And similarly, you have limit x go to A from the right of fx equal to negative infinity. So it's going to be very negative large. So it's going to become like a negative 10 to the 6 or something that I used to mention earlier. Moreover, if you have x go to positive infinity or go to negative infinity, so I told you last time that you have positive infinity here and negative infinity here. And you have x go to positive infinity. So this guy gonna go to positive infinity. And when x go to negative infinity, this guy gonna become lower and without an upper bound in this case. So it's gonna go to negative infinity. So we be able to use the notation limit x go to infinity of fx equal to positive infinity and limit x go to negative infinity of fx equal to negative infinity. So this one you are having is from the graph, and how to describe this thing is going to be these two notation. Okay, and I would want to remark that positive infinity and negative infinity, you have this thing are not real number. We do not use infinity to a normal calculation unless specified in a special cases. And I used to tell you that you have infinity plus infinity equal to infinity. So this one is no doubt. Infinity multiply infinity is turned out to be infinity. This one is also no doubt. However, you're going to have infinity minus infinity. This guy is indeterminate form. And when you have infinity over infinity, this guy is also an indeterminate form that we have no conclusion yet, and we need to simplify. Okay, and we're gonna have two normal function or two elementary function about the log function and about the tangent function. If you recall the graph of the log function, so you have this guy and this guy, and when you have the graph of the log function, you have the graph look like this. Okay, so this one is y equal to log x, and this one is x, this one is y. Okay, and you see that the graph of the log function tells you that when you have x approach 0 from the right, you are going down like this, and it's going to be limit x go to 0 from the right of log x turn out to be negative infinity. And you have on this side, so if you are talking about limit x go to infinity of log x, so this guy turned out to be infinity. Okay, or you may say that log infinity turned out to be infinity, so it's going to go to positive infinity. Okay, and you have limit x go to pi over 2 from the left. Let's recall about pi over 2. So you have pi over 2 and negative pi over 2. So you get pi over 2 here. And you have limit x go to, you have the function arctan give you in the way that you have something like an s here. Okay. And this guy, you see that you have x, you have y. For this function, this one is y equal to tan x on this interval, negative pi over 2 to pi over 2. And you have limit x go to pi over 2 from the left side is here, and it's gonna go to positive infinity. Okay, so this one, we can conclude this one from the graph of tan x. Okay, so this is gonna be two important limit that we will use in the future as well. The thing that I need to teach you will be, I want to teach you how to show that limit x go to something of fx equal to positive infinity or negative infinity. The thing that you see is going to be, you have the symbol. So you need to conclude that this guy turned out to be positive large or negative large. Okay, so it's going to turn out to be positive large or negative large. In order to have the limit is very large, so we gonna have limit x go to the reciprocal equal to 0. So in order to have the limit equal to infinity or negative infinity, the limit of the reciprocal turn out to be equal to 0. And another thing will be, you have to determine the sign. Okay, so the sign that you have for positive or negative turn out to be, you gonna determine the value of the function. So when you have limit x go to negative infinity, it means that you have x large negative, okay? And x large negative mean that you have x kind of less than negative 10 to the 6, okay? And you have x go to positive infinity, okay? So x go to positive infinity, it mean that x go to x more than 10 to the 6. Okay, so it's going to be like this. And you have limit x go to a, okay, from the left from the right. So in this case, it's going to be x less than a. Okay, so it's going to be x less than a from the left. And you're gonna also say that it's not gonna far from A, so it's gonna be like A minus delta for some small delta. So delta here is denote the number that very small, like a 0.1, 0.001, something like that. Okay, and you have x go to A from the right, it's gonna be this guy x more than a, but it's not more than a much, so it's going to be just x less than a plus delta. And if you have x around a, so you're going to use the notation x go to a like this, and it's going to be x around a, so it's going to be x around a, x between a minus delta and a plus delta, and x not equal to a. And you're going to determine the sign. If the sign of fx positive, you will write positive infinity. Okay, so you see the corresponding here that you have fx positive, you have positive infinity. If you have negative for fx, it's going to be negative infinity. Okay, so this is what you have. Let's see from this picture. Okay, in order to determine, I'm going to teach you the more calculation example. Don't be afraid on this one. It's not going to be using like this table or something. I'm going to teach you how to write down and how to show the limit later. But before I do that, let's take a look at this graph. So the question asks you several things. So the question asks you limit x go to 2 from the left of fx. Okay, so you see that you have 2 here. And the question asks you limit x go to 2 from the left, limit x go to 2 from the right, and the limit x go to 2. So the limit x go to 2 from the left side, you see that you're going down, you going down also. Okay, so limit x go to 2 from the left of fx, in this case is going to be negative infinity. Limit x go to 2 from the right of fx turn out to be positive infinity, and limit x go, it's going to be negative infinity as well. And you have limit x go to 2 of fx. So you see that both of them approaches at the same direction in this case. So it's going to be negative infinity. And you have limit x go to negative 3 from the left. Okay, so you have negative 3 from the left side. It's going to be going up like this. So it's going to be positive infinity. And limit x go to 3 from the left side is going to be negative infinity, and from the right side is going to be positive infinity. Okay, so this is what you can see from the graph directly. So you're going to write down it's going to be negative infinity and positive infinity, and you see that they are approaching different direction. So you're going to get jump. Okay, so you're going to get a jump here. So when you have a jump here, you're going to say that the limit does not exist. Okay, so this guy will be does not exist. Okay, so in this case, the limit does not exist. And you have limit x go to negative infinity. Limit x go to negative infinity of fx. Limit x go to negative infinity of fx. So you have negative infinity here, positive infinity here. So limit x go to negative infinity of fx. So you see that this guy gonna approach. Okay, so the graph you see horizontal asymptote. And in this case, you see that the limit x go to negative infinity is approaching 0. And limit x go to infinity of fx turn out to be 0. Okay, and limit x go to 5 of fx. So you did at 5, you see it's go from the left to positive infinity. It's go from the right. It's going to be also positive infinity. So it's going to be equal to 0. Okay. Oh, sorry. It's not 0. It's infinity. Okay. So this one, another thing that I want to mention will be, you see that if you look at this line, so if you are looking at this line and this line and also this line, they are have something in common. They are having something in common. So this guy will be the thing that we call vertical asymptote. So this one is vertical asymptote. Okay, so this guy, they are vertical asymptote. Okay, so you have 3 vertical asymptote. So we're gonna have some example for working example. So you have limit x go to 1 from the left of 2 plus root x over x squared minus 1. So for this guy, you like to determine whether it's going to be positive infinity or negative infinity. So in order to test that, the thing that when we like to have positive infinity or negative infinity, the thing that you should get will be if you plug in, okay, try to plug in first. It's gonna be 2 plus root 1 over 1 square minus 1. So it's gonna be 3 over 0. And you see that this guy is 3 over 0. So it's gonna be the thing that I normally say to students that this is the behavior of 3 over small. When you have 3 over small, so this guy is number 0. However, in terms of limit, it's not gonna approach 0. So it's gonna be 3 over something very close to 0, very, very close. So it's gonna be 0.0000 like this and 1. Okay, so if you have 3 over something like this, so you're gonna see that, hey, this thing is gonna be 3 and you have many, 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 many 0. Okay, so this guy turned out to be really large in this case. Okay, so the thing that gonna tell us that the limit equal to infinity or negative infinity or positive large or negative large turn out to be you gonna have 0 on the bottom like this, and you're gonna have non-zero on top. So if you have the numerator non-zero and you have the denominator equal to 0, that is a good candidate for the limit equal to infinity or negative infinity. Okay, so in this case, you're gonna plug in. Okay, so in this case, you're gonna plug in and you're gonna, okay, so this one turned out to be large. So we're gonna proceed by doing number 1 and number 2 here. Okay, I'm gonna teach you how to write the reason down. So in this case, you get what number, the first case. Okay, so it's gonna be, let me use other color. So you see that the first case will be you're gonna take the limit of the reciprocal. So the limit x go to -1 and you just flip this one. So you flip this one, so you get x squared minus 1 to 2 plus root x. And in this case, you're gonna get 1 square minus 1 over 2 plus square root 1. So you get 0 over 3. So this guy become 0. Okay, so you have the limit reciprocal equal to 0. The second one will be the sine of the function. So if you like to determine the sine of the function, you're gonna take a look where your x will be. In this case, your x is going to 1 from the left. Okay, so I'm gonna say sin x going to 1 from the left. So you have x less than 1. Okay, so you have and near 1. Okay, so you have x less than 1 and near 1. So you're gonna draw a picture, a small picture here. So you have 1 in the middle. Okay, so you have 1 in the middle and you have x less than 1 but near 1. So it's gonna be somewhere around here, right? And you're gonna pick one number for me here. Okay, so you just pick one x here. So you're gonna pick one x. So in this case, x will be you just pick one number. So it's gonna be x equal to maybe 0.99. Okay, so you may say that x equal to 0.99. I'm gonna pick it. So after you pick x equal to 0.99, okay, so you pick x equal to 0.99. So you pick x here to put into the function, to put into the function. Okay, so you pick x equal to 0.99 to put into the function. So you get 0.99, not 0.99, so it's going to be 2 plus square root 0.99 over 0.99 square minus 1. Okay, so you pick this number and you put into the function, and the thing that you will get will be the number. However, we're not gonna need the exact number, we just need the sign of this number. So you see 2 plus square root of something like this is gonna turn out to be positive on top, and you have 0.99 square, so this guy will be less than 1, right? And minus 1, so it's going to be negative on the bottom. So in this case, the total sign turned out to be negative. Okay, so the sign that you have for this function turned out to be negative. Okay, and you have number 1 and number 2 already, so you get this guy number 1 and this guy number 2. Okay, so you have the limit equal to 0 and you have the sign of the function negative. So the conclusion that you can draw here turned out to be, you're gonna draw that limit x go to 1 from the left of 2 plus root x over x squared minus 1 is negative infinity. Okay, so the thing is you get infinity from the first one. Okay, so because the limit of the reciprocal equal to 0 is going to be infinity or negative infinity depending on the sign of the function. And the second step will give you the sign. Okay, so the negative infinity here, the negative sign come from, okay, so the negative sign here come from the sign in the second step. So the first step give you the symbol infinity. The second step will give you the sign. Okay, so this is how we determine the infinite limit. Okay, let's do 3 more, I believe. So for this one, you have limit x go to 3 from the right of 2 to the x over x minus 3. So you're gonna find the limit of the reciprocal. Okay, so let's find the limit of the reciprocal here. So you get number 1. So you get limit x go to 3 from the right of x minus 3 over 2 to the x. And in this case, it's going to be 3 minus 3 over 2 cubed. So it's going to be 0 over 8 equal to 0. Okay. And number 2, okay. So you're going to have to check the sign. So you're going to say since x go to 3 from the right, we have x more than 3 and near 3. So in this case, you're gonna have 3 in the middle and you have x near 3. So it's gonna be somewhere here. Okay, so it's gonna be from the right side. And you're gonna pick one number for me here. So you're gonna pick, okay, so you're gonna pick x equal to what? You're gonna pick x equal to something more than 3, let 3.02. So you can just pick x equal to 3.02. So you put into the function. So we have 2 to the 3.02 over 3.02 minus 3. And this guy turned out to be 3.02 over 0.02. We don't care about the exact value. We just care about the sign. So in this case, it's going to be positive over negative. Okay. So, sorry, positive over positive. So it's going to become positive. Okay. So in this case, you're going to conclude from the calculation in each step that you have this guy limit equal to 0, and the second case, the second guy will be positive. So the conclusion for this limit turn out to be limit x go to 3 from the right of 2 to the x over x minus 3 equal to positive infinity. And you see that the green guy give you the symbol infinity. Okay, the green one give you the symbol infinity. So this one is number 1. Okay, and the blue one give you the sign, the positive sign. Okay, so it's going to be 2 steps. First step give you the symbol infinity. The second step will give you the sign positive or negative. The next one, you have limit x go to 0 from the left of x squared plus x plus 1 over x minus x. Okay, so for this one, you're gonna find the limit of the reciprocal. Let's put x equal to 0 first. When you put x equal to 0 for this one, it's gonna be 1 over 0. Okay, so this is the candidate for infinite limit. So you're gonna find the limit of the reciprocal. So you have limit x go to 0 from the left of absolute x minus x over x squared plus x plus 1. So you get absolute 0 minus 0 over 0 squared plus 0 plus 1. So it's going to be 0 over 1 equal to 0. Okay, so you have the limit of the reciprocal equal to 0. And another thing will be you're gonna find the sign. Okay, so you have sin x go to 0 from the left, so it means x smaller than 0. Okay, so if you not be able to see it right away, you're gonna have to draw one picture like this, and you have 0, and you're gonna have x in this interval. So you're gonna pick one x for me. So in this case, you're gonna pick x smaller than 0 but close to 0. So it's gonna be negative 0.01 kind of. Okay. So you have x equal to negative 0.01, negative 0.01. So and x and this guy near 0. So we can plug in, so you get negative 0.01 square minus 0.01 plus 1 over absolute negative 0.01 minus 0.01. And you see that on top, you get positive sign. On the bottom, you get 0.02. So it's going to become positive. Okay, so we're gonna conclude that the limit x go to what? The limit x go to 0 from the left of x squared plus x plus 1 over absolute x minus x turn out to be positive. You see the color here, and you have infinity. So the black guy give you the symbol infinity, and the second step gives you the sign. Okay, so it's positive infinity. The next one, you have limit x go to positive infinity of 3x plus x squared over x minus 4. Okay, so you have 3x plus x squared over x minus 4. And you see on top, when you plug in, it's gonna turn out to be infinity. On the bottom, you plug in, you also get infinity. So it's infinity over infinity. How would we know that it's gonna become infinity or negative infinity, or it's gonna be real number? So the thing that you may have to notice from this question will be, you're gonna see that when x go to infinity, this guy is infinity square. Okay, so the yellow guy here will give you infinity square, and infinity square is very, very big number. Okay, on the bottom, you get only infinity. So on the bottom, you get only infinity. So in this case, you see that the top guy or the numerator should win because of you have square here. So it's not same level. So this one is infinity to the first, this one is infinity square. So this one should win. Okay, I'm gonna just say should win. I don't know it's gonna win yet. Okay. So we're gonna have to do two limits in this case. So we're gonna have to find the limit of the reciprocal. Let's find the limit of the reciprocal. So the first one, you're gonna find limit x go to infinity of x minus 4 over 3x plus x squared. And this one, you see that we are working on the limit x go to positive infinity. So it's not factoring. It's going to be, you're going to have to pull out highest power. So it's going to be x 1 minus 4x 4 over x. And you have x squared 3 over x, 3, you pull out x squared, so it's going to be 3 over x, okay, minus, so you get 3 over x plus 1, okay, like this. And you see that it's going to become 1 over x, it's going to be 1 over 4 over x, it's 3 over x plus 1, okay. And you see this guy gonna go to 0, this guy gonna go to 0, this guy gonna go to 0. So this limit become 0, and the black guy is 1 minus 0 over 0 plus 1. Okay, so in this case, it will turn out to be equal to 0. Okay, so this guy will be equal to 0. So you have the limit x go to infinity of the reciprocal equal to 0. The second step will be you determine the sign. So when you have x go to positive infinity, so you say sin x go to positive infinity, so it means x is large, and you're gonna draw the line here. So you have x large, so it's gonna be x is here. Okay, so you're gonna pick x. Okay, so you're gonna pick x equal to something large like 10 to the 6. Okay, so you pick x equal to 10 to the 6, 1 million here. So we have 3 times 10 to the 6 plus 10 to the 6 square over 10 to the 6 minus 4. And you see that on top is going to be 10 to 12, okay? And on the bottom, so it's going to be, I not want the number, so I want the sign, so it's going to be positive. And on the bottom is also positive, so it's become positive. So in this case, you're gonna have limit x go to positive infinity of 3x plus x squared over x minus 4 equal to positive infinity. Okay, so it's turned out to be positive infinity for this question. Okay, so you see that in order to determine the infinite limit like this, you're gonna need to do two steps always. The first one will give you the symbol infinity. The second one is gonna give you the sign. Okay, try to do example, and the thing that I should mention will be I will suggest you to do these exercises from the textbook. Okay, so this one come from the textbook 2.2, 2.3, 2.5, and 2.6. They are from the textbook that post on the blackboard, and you can follow the thing that I lecture you to be able to do this similar problem. Okay, so this one are similar with the thing that we did on the lecture. Okay. Okay, before I finish this one, I have one mistake to correct. Okay, so let's go back to page. It's gonna be on page here. It's gonna be on page 27. Okay, so let's go back to page 27. Okay, and I think I forgot the minus sign here. Okay, so you have this guy, -1. So I forgot the minus sign here. So please have negative sign. Okay, so it's going to be negative sign and negative sign. Okay, sorry about that. Okay, so this one is going to be negative sign. If I did any mistake, so just tell me, okay, by private message, or you just lie me that, okay, you make mistake, I gonna fix it in the later clip. Okay, so this one is the whole thing for this slide. Okay, and this one will be all of the thing that you should study right now. Okay, so this one will be about the infinite limit. Okay, so we have all of the thing that we should have. Okay, so this one we talk about the tangent problem, the area problem already, the limit of the function, the calculating the limit using the limit law, the limit at infinity, horizontal asymptote, and how to determine the infinite limits already. So this one is the conclusion for all of the limit. Okay, the next topic that we're gonna study, we're gonna use the limit definition in order to compute the derivative of the function.